just about there. At this point, we'll just run the clock, but at this point, we also have the class recording going. Well, I think it's official, folks, so we can now begin. So welcome to trigonometry. This is a 2-credit, 50-minute class, and it's really a pretty fun one. All we're doing here is extending the information that you learned in college algebra. So we're adding to your catalog of functions. In college algebra, we looked at linear, quadratic, rational functions, exponential functions, and the logarithmic functions. Here, we're just looking at the trigonometric functions and of all their inverses. So we're going to start off first by just taking a look at the Moodle website, getting ourselves oriented on here. We'll go through the syllabus, not a line by line careful reading, but just a quick look over it and point you in some directions on what to look into further. But before we get started, any questions or comments at all, folks? Okay, maybe the first thing we should say is, well, we have two classes. Section 2, this is the in-person section. And section 22, this is the synchronous online section. So kind of a weird setup we have here, but we'll definitely make it work. And that means all of our classes are definitely going to be given over Zoom. But if you are registered for the in-person section and weather is really bad or anything kind of emergent happens, you're also welcome to use a Zoom link. So don't feel as though you can't use that just because you're in section 2. In fact, the weather is so bad that I heard that DoorDash canceled their operations in East Idaho for 24 hours. So that's some of the craziest weather I've heard in a long time. And that'd be a good time to use the Zoom link if you just didn't feel safe driving. If you did miss a class, we're going to record all the lectures and they're going to end up here into a YouTube playlist. Other things that we can take a look at on this website are, let's see, this Desmos right here. This is mostly for just doing quick graphics, plotting functions in class. And this right here is a brand new thing I'm trying out this semester. We have a Discord server for homework help. You don't have to use it if you don't like it, but it's mainly for asking general questions, doing group work and study groups kind of thing. Let's open it up just to take a look at it. So I'm new to Discord this semester. I'm not even sure what this is. I'll just click that away. So if anything looks like it's set up weird here, let me know and I'll try to fix it or make it slightly better. This is what it looks like when you jump in. And for our class, trigonometry, this is how you could use it. You can just ask general questions. You'd be getting help from your fellow students in this class. We're a class of about 23 students altogether. I'll try to jump into the server here as well, just to help out where I can. And your questions could go along these lines. You might be working on assignment 1. It says to do these problems on page 455. One cool feature about our class is, here's the book. It's free, just like we had going on in college algebra. And in this book, you could go to, let's see, we're in section 5.1. And let's suppose, even though it's not assigned, that maybe you're doing this problem, say, for example. You could take a screenshot of this, and if you're on a Windows machine, the screenshot is click on the Windows key, the Shift key, and the S key simultaneously. Your screen will go a bit dark, and just use this cursor to select the region you want a screenshot of. Maybe something like that. Then you can go to the Discord server, hit Control V, or right click and paste it in. And you might write to the entire class, hey, does anyone know how to start these? And you're well on your way to interacting with the class
for a long time. I need to make them.
Oh, sorry, what was that? Did I miss a question on the Zoom? Oh, gotcha. And Zarek asks, I don't know how Don't know how it is for other people, but the Discord link isn't working for me. Oh, strange. I'll try to take a look at that, Zarek. Let me put down a quick note here.
Yeah,
Okay.
it's not working for me too. It says like this invite may be expired or you might have not permission to join.
Oh, weird. You know, I think it comes from this. And oh yeah, these expire in 7 days. I had no clue. That's, I could just click on copy, I guess. I'll make sure to come fix that for my other classes, but for us, let's just fix it right now if you want to jump in. Oh, thanks for spotting that for me. Really bad at this stuff. Probably should have practiced a little bit more before starting it up, but there it is. Oh, that's really cool. Thanks for spotting that. What did it do? It just knows that when it uses that, it's this one's set to keep on going. Let's go back over here. And oh geez, where am I? There it is. Edit this out, and here's the new link. Okay, that all one should work out for you, Zarek. Let me know if it's still giving you any trouble on there. Other questions so far, folks, about anything at the moment, Discord server or otherwise? Okay. Well, when you see these kinds of questions, anyone in the class is welcome to jump in. You're welcome to post your own, and I'll try to help out as well. If you want to do a study group, you also have a voice channel here where you can screen share, communicate over voice, and that'd be an interesting way to form a study group with both sections, whether you're in Idaho Falls or on the Pocatello campus or otherwise. But I want to also emphasize all of this is optional. This is just one way to get help in this class. If this looks janky and you don't like it, you're just fine for it. You would never lose out on any course content or any points in the course. Other ways to get help? Well, we'll take a look at the syllabus. And in the syllabus, if you need to get help, here's where our office hours are going to be. I did revise this, and my revisions are in red. I added a Tuesday, and I said in Zoom as well for these days. So I'm available 4 to 5 p.m., Monday, Tuesday, Wednesday. This is in my office, tab 268 in Idaho Falls. But for the section in Zoom, you can also jump in and Zoom as well. These are kind of a free-for-all walk-in type, first come, first serve basis office hours. So if there's people in the office tab 68 and in Zoom simultaneously, we just go in order. So we'll go from one question to the next. Likewise, I'll be in Thursdays, 3 to 5 p.m. and also in Zoom in room 220. That's going to start next week officially since room 220 is closed at the moment. That's going to be our math center here on the Idaho Falls campus. Well, now we have the syllabus open, we might as well kind of run through it still. First, any questions at the moment, folks? Okay, so you can get help through the Discord server, or if you don't like it, you can get it directly from me. Those are my office hours, and you can also contact me by phone and by email. I'm also very responsive on the email as well, so things you can email me are really no different than on the Discord server. You can send me direct questions about what you're working on, and I'll be happy to help out. Our course text, like we mentioned, is completely free, so that's the nice thing about this course. You don't have to buy anything extra. So that's our textbook right here. When it says do problems out of the textbook, page 460 or something like that, it's referring to this right here. We also have a calculator policy. These are the 2 allowed calculators on exam. We'll discuss that a little bit more detail as we get closer to exams. But our calculator policy starts on exam 3. Exams 1 and exam 2 are going to be closed calculator, but that's just because of the nature of the trigonometric functions themselves. We're going to learn how to evaluate them by hand. And then starting on exam 3 and the final exam, we'll open it up to calculators where we'll be doing more applications where we need to approximate things. Any questions about that at the moment? Okay. Let's go through the prerequisites, objectives, and let's take a look at the homework for our next thing to go through. I wrote here, homework will be assigned daily, but here's how homework is really going to go. On the Moodle website, go to the current week and you'll always know what lecture we're about to go in. There'll be section 5.1. Anything that's moved over slightly to the right is optional reading or just additional resources for those notes. And the moment we finish the section 5.1 notes, there'll be a 1-week turnaround of the due date for the assignment down below right here. Now notice the due date is January 23rd on this assignment. And that means I'm thinking that we're going to really finish it on the 16th when we come back next week. I'm not intending to finish all of 5.1 today. That's kind of a rough race through the introductions and a whole section there. So that's how the assignments will really work. It won't necessarily be daily unless we finish a section on one day and another section on the next day and so on. Well, that's how the homework is going to work. And in this class, it's pretty much traditional. You can solve your homework problems on ordinary lined notebook paper, college ruled paper, staple them, and then just drop them on the table here at the start of class. If you're in the online section through Zoom, what you would do is take a scan of your homework or just an ordinary cell phone pictures of your homework works and email it to my ISU email address right here. So I'll be taking your homework digitally in that way. And really anyone's welcome to email your homework. So if you're in the in-person section, you decide you want to just email me your homework, that's okay as well. So that's how the homework is going to work. Again, it'll be pretty traditional. I wrote here, students are encouraged to work in groups for the homework set, highly encouraged. That's a really great way to learn this content. You do have to write down your own work as well. And this is kind of standard stuff you'd expect from math class. It says, you do have to show your understanding on the problems by showing step-by-step solutions. So if there's steps that we showed on the lecture, there's probably steps you have to show as well on your problems in the homework. You have to use correct mathematical notation, and we'll say what that means each time it comes up, but the idea with that is we're dealing with functions and function notation, so we can't necessarily say cosine is a number. We'd have to say cosine of some angle using the proper function notation. We'll try to simplify our answers, but we're also going for exact answers. This is the reason why exam 1, exam 2 is closed calculator. Actually, having a calculator has caused people's exam scores to go down because we're looking for the exact output to the trigonometric functions, not their approximations on those. But if a problem asks for approximation, that's when we will go for it. That's starting on exam 3 and the final. So in other words, this is just a preview, but here's what we're meaning with all those comments. We'll want to calculate things along the lines of cosine. Sometimes the output for the cosine will be √3/2. But we wouldn't get full credit for a statement like this because this is not proper function notation. Cosine is an entire function. It's not equal to that. That's one number. We'd have to say cosine of a specific input. Now we're using the correct mathematical notation and give it the angle pi/6. So cosine at pi/6 equals the √3/2 that we see right here. And again, exam 1 is closed calculator because it's actually really easy to mistakenly put in the approximation when we want the dead-on exact value for these outputs. So that's what's going on with this paragraph here. Any questions or comments about that so far, folks? Yeah.
For when we take exams, are we allowed notes or?
There will be closed notes exams, but I do put some of the formulas on the exam itself. So each of the exams are going to have a formula sheet for the kinds of things that you wouldn't have to memorize verbatim, but you'll be able to use directly on the exam. So there will be closed notes with actual notes on the last part of the exam. Does that make sense? Awesome. And as we get closer to the exam dates, they're also posted here on the Moodle website. Our first one is going to be Tuesday, February 6th. I'll be posting extra documents, the exact coverage of the exam 1, which sections. I'll post the actual formula sheet that I'm attaching, so you'll know what notes are going to be provided to you. And I'm also going to be posting review problems, so you'll have extra problems to practice as well for each and every one of these upcoming exams. Well, other questions at the moment? Okay, any questions so far in Zoom, folks, at the moment? Oh, we got a chat. Higgins asks, when submitting the homework, do we just take pictures of it? Yeah, if you're, say, coming in through the Zoom, what you would do is solve your problems on ordinary paper, pretend this is ordinary paper. You could scan it if you have a scanner, but I'm completely fine with ordinary cell phone pictures. If you send me a file that I can open, whether it's a PDF, a Word document, or otherwise, then that's always acceptable for submitting your homework. And just send it to my ISU email address. And what I'll do is I'll take your homework assignment, pretend this is your homework assignment. I'll mark it up. Things like this, checks means you got it right. X's with a comment means something might have went astray. I'll save it as a PDF and then just email it right back to you. So that's how you're going to get your feedback for the online section. For the in-person section, if you email me your homework, I'll do the same exact thing. But if you give me a hard copy, I'll mark it up the way you'd expect with a grading pen and then hand it back to you physically. Other questions, folks, about any of those things with homework or otherwise? Okay, let's see where we're at so far. We discussed homework. Now let's go to examinations. Don't have a whole lot to say here. I mean, there's a lot of comments, but we'll address these a little bit more directly once we get closer to the exams. Like it was asked about, the exams are closed notes, closed book. Exams 1 and 2 are also closed calculator, but exam 3 and the final will be open, and all exams will have some notes on there. So I'm not asking you to memorize everything. Actually, this class is hard to memorize everything. There's a lot of formulas in certain sections, and I do provide some of those formulas. You'll have to be fluent in using them, and that'll be the main concept that's being checked on the exams. Well, any questions, folks, about the examinations? Okay, because this is a 50-minute class, the exams have to be short. I cannot give a 75-minute exam in this class. And so when I go to write an exam, really what I'm going to try to do is write a 40-minute exam. So there'll be about 10 minutes built in for checking your work and that kind of stuff. So I'm not going to try to write a huge exam that you're going to work right to the minute of 50 minutes, writing as fast as you can. You'll have a good opportunity to demonstrate your understanding on those problems without feeling rushed. Well, beyond examinations, here's the breakdown for grading. Homework is given a lot of influence. In my opinion, that's worthwhile in this class. That's the best way to succeed, is getting in lots and lots of practice on these concepts. Each one of the, oh geez, hang on. That's a typo. Let me make a quick note here. I need to fix that. It should have said average of exams 1 through 3, or 1, 2, and 3. Fix grading on syllabus. Okay, I use a lot of Post-its since I don't have a wonderful memory for every little issue that could come up. And in the chat, Jamie asks, where will we take the exams? Oh, that's a really good question. Thanks for asking, Jamie. So for folks in the Idaho Falls section, it will be right here in the class as a physical exam. But for people in section 22, coming in on the synchronous online, it's going to be at the Pocatello Testing Center. And I know for some folks, you might be at a slightly different satellite campus, and I'll just go for the closest testing center to you. So let me know if the Pocatello is not the closest one. You might be closer to Idaho Falls, for example. I could give it to you in the Idaho Falls Testing Center, Twin Falls Testing Center, and so on. So you're in Jerome. I am really bad at geography. I'm going to have to take another look at that, but Twin Falls? Okay, gotcha. So that would be in the Twin Falls then, Jamie. Other questions about that so far? Yeah.
As far as grading, do you, say that you get the problem wrong, or when you answer wrong the problem that, that so accurate, you get that credit at all?
I do give partial credit, absolutely. So kind of the idea of the partial credit is if you had the right answer, but all of the work above it was just completely wrong, I might give you 1 point out of 5. I mean, you had the answer, but if everything is wrong above it, we don't get a lot of credit. But if your process is correct and your answer is wrong, maybe you had a negative sign or something like that, I would probably give 4 points out of 5, occasionally 4.5 points out of 5. If you have the understanding, but there's simple mistakes that were not major to the actual concept of the question, you get most of the partial credit, almost all. Does that make sense for the grading? Awesome. And the way I grade your homework assignments is going to be similar to how I'm going to be grading your exams. So if there's a comment like show a step here, that means it'd be something that's expected on exam as well. The homework is really just us getting ready for exam essentially. And in Zoom, Caden asks, I'm about 8 hours away in Spokane last semester. I took my exams at Spokane Public Library. Can I continue this? I'm not completely sure on that one, Caden, but that's something I can run to my department chair and get that situation there figured out. But let me just make a quick note. Hayden and Spokane. Where to take the exam. Okay, I bring lots of posts, so don't be concerned if it looks like I'm starting to run out. Yeah, go ahead, Michael. Okay, no worries. Other questions so far? Okay, these are all really good questions. Thanks, folks, at the moment. And Hayes asks, will you give us more information near the exam, like where, when exactly? Yes, absolutely. Pretty much what I'm thinking about doing on week 2 is I'm going to send out an email to everyone in the class, just asking, where is your preferred testing location? If there's weird issues like we're not sure, say, for example, what Kaden was mentioning, we'll get it worked out one way or another. Does that make sense, Hayes? Awesome, I'm glad to hear that. So yeah, this kind of course is a little bit stressful in a certain sense because there's a lot of little things to figure out. But I have ran a course like this before in prior semesters. We always get it sorted out one way or another. Any questions at the moment at all, folks? Alex says Twin Falls ISU satellite office is the CSI Hempworth building, if I remember correctly. Awesome, that's good information right there. Well, this is pretty much our syllabus. If we scroll a little bit further, we're not getting into anything too terribly. Well, yes, we are. We're getting into the day-by-day schedule. That's important. Because of the inclement weather, we canceled on this day, so we're going to adjust the schedule a little bit. But the schedule is tentative. The only things that are firm are the exam dates. Exam 1, 2, 3. And our final is going to be on, you know what, I forget. Let's take a look. The final for our class is going to be held on Tuesday, April 30th. I'll have to double check on the time, but for a night class like this one, they usually slot it from 8 to 10 p.m. That's kind of rough, but we get through it. So that's the day-by-day schedule here. We have to adjust occasionally, but not just because of the snow day that we took here. If, for example, we just decided section 7.1 was tough, we'll take an extra time to make that section happen. So we can adjust here and there to make the schedule work. Scrolling even further down below, this is all the university resources. I would encourage everyone to take a look at these pieces of material, especially if something looks unfamiliar. For example, if you've never heard of Title IX before, it's extremely important that you read all of the statements right here. And a chat asks, I think 19th of February is a holiday. I believe so. That one should be President's Day, correct? Let me see here. Should have it. It's March. It'd be up here in February. Oh, but that's a Monday. And we run on Tuesday, Thursday. So my schedule is a little bit confusing. I think I understand your question, Kiana, or Hayes. So it says week of 8th of January, but our first class is really the 9th of January. So this is just the Monday day. Does that make sense there? Gotcha. So unfortunately, we kind of just missed all the holidays if it's a Tuesday, Thursday class. That feels like we got cheated in some way, but we took a snow day for consolation, I guess. Well, that's pretty much our whole syllabus so far, folks. Like I mentioned, everything beyond university resources was written by somebody at the university other than me. And there's some really important stuff in here. Accessibility, academic integrity. We mentioned Title IX. And this one's a good one to highlight as well. If things are not going quite right in your class, in this department, whether it's this class or another one, you have avenues, and it's better to act sooner than later. Something is just not fair, not correct, or just doesn't seem right. Our department chair is Dr. Ralt, and he has his email here. We also have Dr. Snyder as well, our folks you can mention. This is the dean of the college as well. And so those are avenues that you could go down as well. Well, we did it, folks. That's the reading of the syllabus. We're about 24 minutes in, but that's good. That means there was a lot of questions. Any other questions at the moment? Okay, well, let's jump back to the Moodle website. And effectively, all this Moodle website is just going to be kind of like a paper trail or one large resource for everything we do in this class. Everything you could want for getting through the class is going to be in here some way, shape, or form. We took a look at the Discord server. Again, this one's completely optional. This is optional reading down here, but this one especially I'd say is good to take a look at. It's study habits for math in general. And it's also a very large website with lots of review content, college algebra, things like that. If you're getting into calculus, then this website, How to Study Math, is much more legendary than it looks. This is Paul's online notes. He's at Lamar University. And all of these things right here, these might as well be full-blown textbooks. It's a very professionally written website, even though it looks like it's old. It is old, but it's great content. Algebra review could be found here and that kind of stuff. So this is my big link for if anyone asks me what's a good website to review math, study math, things like that, this is usually my one-stop link for that kind of stuff. Next thing that's kind of curious here is I put a document, it's a folder called Blank Lecture Notes. It contains, oh, I forgot to actually put them in, but I will put in the blank lecture notes inside here. And the purpose of that is once we solve section 5.1, in fact, once we end class today, no matter how far we got into it, this file, which is a PDF, will get updated with our solutions we put in. But sometimes that's a bit of a not the greatest thing for folks. If you want to print this out, you can find the blank ones always right here once we start filling out the solutions. Well, that's our Moodle website and a rough sketch of what we're about to do in this course. Any questions or comments or concerns at the moment, folks, whether in class or in Zoom? Okay, I think we're ready to do just a little bit of math. We end at 7:50, but today is our starting up day and the weather is terrible. So we're not going to try to go up to the minute. We'll see a decent compromise for a stopping point. So we're in section now 5.1. And when you're doing this course, there's a lot of ways you could do this. You could say, print out section 5.1. It's now effectively just one large worksheet where you're going to fill in all the information like we are in class. You might download it, work on it digitally. That works out pretty well for folks. Or just working standard notes, blank, and just putting in what we put in is a great way to go too. One thing that's a little tough, and the reason I put out these notes is you don't necessarily want to try to write down all of these things. They're copied right out of the book itself, and that's not the best use of taking notes. You want to take down the notes of the things that we add aside from these core definitions. Well, I think we're about ready to get started, so here's the Word document that we'll be using. This is kind of like a white space board at this point. Let me just arrange my windows a little bit. There we go. And a new chat asks, are we permitted to use rulers on the exams? You know, that's a good question. I'll have to make a note of that since usually when we write out exams, we have to say what all the required materials are. So if you feel like you might need a ruler, maybe the best thing would be is just email me before we go to schedule your exam, and I'll make sure that that's something that is allowed on the actual exam itself. Does that make sense with that question there, Alex? Okay. Well, let's keep on get to the section here. This is our first start. We're doing chapter 5, trigonometric functions. Now, the trouble with trigonometric functions is if you're going to define a function, you have to start with its domain. That's the most important thing. Where are the inputs to your function? So the domain of the trigonometric functions are angles, but it gets even worse than that for introductory section. We're not typically going to be using angles like 45 degrees. The type of angles we're going to be using are these kinds of things. The domain is all angles using radian measure. Let me force in some extra space here. So really the major takeaway of section 5.1, we're just trying to get used to radians. But if we're going to get used to radian measures, we need to start with something common, and that is ordinary degree measurements. So here's our first initial definition. It says in elementary geometry, an angle is formed by two rays with a common endpoint, and that's going to be the vertex. Let's throw that there. Here's our vertex. But instead of writing down two rays, here's a great way to visualize this. We're going to have two overlapping rays to start with a common endpoint. So here they are. Imagine there's two rays right here. They're overlapping. They start at the vertex in this location. The ray that's fixed will be called the initial side. Now let's maybe change this a little bit. So here's the initial side. And the ray that actually rotates is going to be the terminal side. So imagine two rays overlapped here, but one of them, the blue one, is the initial, and here's the one that rotated away. That's going to be our terminal side. Then the actual angle itself is right here. Sometimes we use letters like the Greek letter theta, maybe the Greek letter phi, and so on to designate our angles. And so that's one side of benefit of trigonometry. You'll pick up some Greek letters. So this is like writing the letter O, but the slash that goes in the middle is prominent. So this is theta. Another common symbol for angles might be this one. You go in with a swoop and come down like that. This one is phi. And there's a bunch of others. I mean, it's the entire Greek alphabet you could put on here. But for angles, these are two pretty common ones that we'd be using. Well, I put here on example one, draw some examples of angles. This is really kind of a warm-up example. This wouldn't be a homework question. But just to tie in the definition, let's throw some angles in there. Any questions at all, though, with the diagram at the moment? Okay, so that's our angle. Its purpose is to measure the rotation of this terminal side when it stopped right here. So some common examples, let's put down first an X and Y axis. We'll do it in a funny way where my initial side goes like this. So here's the X axis. And when we do more and more angles, we typically want the initial side to be the positive X axis. Later, we'll say that those are going to be the angles measured in standard position. In fact, the very next definition. Let's put down a couple random angles here. If you made an angle go like this and called this measurement right here theta, anyone see about what theta would be as a degree measurement? Yeah, exactly. This one would be 45 degrees. If it went, say, from here to here, that would have been 90 degrees. We rotate halfway, so just 45 degrees. If we take another angle, let's say our terminal side is the negative x-axis, going that way, then here's the angle phi, and phi would be equal to 180 degrees. If we rotate all the way around, we're at 360 degrees. Rotate twice all the way around, that's 720 degrees, and so on. Well, that's just some common angles, just to tie together the definition. Any questions at all with those sketches at the moment? Okay, so next, like we mentioned, we're not always going to draw our angles free floating like this. We want our initial side to be specific, tied down to the positive x-axis. And once you start doing that, we're going to say that angle is measured in standard position. Oh, that's example 2. Leave it like that, maybe. We'll say the angle is in standard position if its initial side is a positive x-axis, like we were drawing way up here. But here's the new information. We didn't necessarily worry too much about the sign of the angles, but in trigonometry, we really have to The direction you rotate is just as important as the amount of rotation, and we're always going to use this convention. If you rotate in a counterclockwise direction, that might be too much highlighting, you'll have a positive angle. If you go clockwise, then your angle is now negative in that case. That's a curious convention, but this is the one where everyone sticks to it, so we'll do the same in this class. Any questions about that convention with positive and negative? Okay, let's just draw down a couple angles to get a feel for this. Like before, it's not a bad idea to start by drawing just the ordinary X and Y axis. Here's the initial side in blue. And for our first angle, let's make it be this one. I'm trying to draw an angle that looks like it's 30 degrees away from this initial side here, the blue line, but I'm rotating in this direction. I put an arrow there to say there's a real directionality to this one. Anyone see what that angle ought to be then? Theta? Exactly. Rotated clockwise, so exactly, we have a negative angle. Negative 30 degrees. So all we're doing with this initial example 1, example 2 is just getting a feel for the domain of our trigonometric functions. But we also have to take these things and write them in radians. That's going to be the next concepts we're going after in these notes. But let's draw out another one. Let's go for, how about an angle that goes way out to here? Exactly. So if we rotated just to here by the red dot, that's 180. That's another 45 rotations, so theta would be 225 degrees. But this time we are putting in a positive 225 because we rotated counterclockwise. This was negative because we rotated this one clockwise. Let's put just a quick note here. Clockwise. So negative. And this one is counter clockwise. So that's why we said phi was positive. So positive. So now we have a notion of angles and the magnitude or the directionality, whether we're rotating one way or another. Any questions at all so far with these concepts? Okay, well, let's go off then to our next concept. And this is the big one. We're taking everything that we're used to, angles measured in degrees. That's kind of sad, but if we're doing calculus and engineering and physics, that kind of stuff, you're probably not using degree measurement. You're using radian measure. And all of our functions, in fact, in our calculator, we have to be careful that you say radian measures with the right word, or else we could get completely wrong results. It's always assumed these trigonometric functions input is in radians unless otherwise specified. So here's how it's going to work. Let's put in a little bit of extra space here. It says place the vertex of the angle at the center of a circle with radius r. So we're doing a circle here if we're talking about radians. That makes sense. When it says radians, it's referring to the radius of that circle. So let's draw a circle of radius r to start. Here's the vertex right at the center. We're still doing these in standard position, so I want the initial side to be the positive x-axis, like this. Well, for this problem, it's actually not required, but not a bad practice. I'll write it out this way just as a good practice. So it says here, we have a radius r. That means we also have an equation for this circle. It's x squared plus y squared equals r squared, is how you would specify that. Next, it says, let S denote the length of the arc intercepted by the angle. Let's say what that means. So here's the initial side, the one written in green. We're going to write down an angle. Let's just decide where to rotate to. Let's rotate to about here. Why not? Just a random example. That means this is the terminal side going through here. Let me put that in green rather. And our angle goes this way. Let's call it theta. It's positive, but we're talking about an arc length, S. That arc length goes from here all the way around this circumference of the circle until we get to the terminal position right here. So that's your arc length S. It measures to here, to here. Does that make sense about S at the moment? Okay, all this is really highly dynamic. I'm just not good at animations on a Word document, but if you could animate it, this line overlaps right here, starts to rotate, and it sweeps out this blue region, giving us the arc length. It stops right here for the terminal side. Now what we're doing is, we're counting how many radians is this altogether. In this problem, here to here is 1 radius. So that looks like 1 radius, 2 radii, maybe about 2.2-ish is the number of radii that you could take here and bend around the arc length. So that tells us that our angle theta is going to be your arc length S divided by the number of radiuses, and we say it's radians, or you could abbreviate that to rad for radians. So that's our new definition of angles in radian measure. Now, what we'd want to do with this very next is practice with it. We'll find the radian measurement in this situation, but then what we really want is a conversion factor. We need to know how can we take everything in degrees, convert it back to radians, and this is what we're going to do to make all that happen. I think for us, this is a good picture to come back to when we return on Tuesday's class. I don't want to get too far into the content since we're just introducing the course at the same day today. So this will be our official stopping point. I'll save this right here, and that means pretty much what my workflow looks like is after class is over, I save up the notes, head home, have dinner and that kind of stuff. And the next morning, I'll, before 11 o'clock typically, override this with the solutions we already put down and put our recording right here in this playlist. So all those kinds of things happens on the morning of the very next day. So before Friday at 11, we'll get all this uploaded. Well, this will be our stopping point for today, but first, any questions or comments, folks, about either this content here? I need to get
Yes, for our homework one, you said it's supposed to be due next Tuesday, but we haven't actually learned anything. So is it still on? Do we have to still do it?
Well,
Yes.
the due date is going to be the 23rd, so it's going to be due
Oh, the other Tuesday, yeah.
exactly.
Yeah, I thought it was next week, sorry.
Snow day. Oh, no worries at all. Yeah, if we didn't have a snow day and we finished 5.1 today, then yeah, it would have been due the 16th, but I felt like we're not going to finish it, so it's due on the 23rd.
Oh,
And the
okay.
idea is,
That's why it wasn't showing up on my dashboard because it's like
Oh,
next
gotcha.
Tuesday.
gotcha. Other questions so far, folks? Oh, I missed a chat. And I should mention, chats are really kind of easy for me to miss. It does pop out here, and I might see it, but I get kind of a tunnel vision. So anyone in class, if you notice I missed a chat, it'll never be rude for you to holler out, hey, Mike, you missed a chat, whether you're in person or over Zoom. And Jamie asked, are we going to need to memorize the unit circle? Yes, we'll have to memorize that information there. The major thing we want to memorize is this, common angles and radians. And so this is the information we need to memorize for the purpose of the course, where all those radian measurements are. Once we know where they are, this document contains the output to the first 2 trigonometric functions based off those angles and radian measurement. Our goal is to get fluent with this, so if we see sine of pi over 4, we know the output is √2/2 without having to cite the diagram. Other questions at the moment, folks? Okay, maybe one last thing to leave you with. Another thing I do with my workflow is, if we didn't finish section 5.1 in the week that we're currently in, I go like this. I'm just going to move it down to the very next week, January 15th to the January 21, to move everything down with it. And this is where we're going to officially finish section 5.1, so it lands on this section of the Moodle website. I usually do that afterwards, but sometimes things move around. That's because It's just moving with the week. We're gonna be working on it next. Well, I think I ran out of things to say and stuff like that. Any other further questions or comments at the moment, folks? Okay, well, have a nice night, folks. Drive safe if you're driving. And when we return on Tuesday's class, this is exactly where we're gonna come back to. Example 3, probably refreshing this as well. Well, have a great holiday, have a great weekend, and we'll come back on next week. Thanks. Oh, another thing I was going to mention, but I did forget. This is my last class for the night. So if you did have additional questions, I'm very happy to help out after class. You can hang around in Zoom for a bit or in person for a bit, and I can help out. Usually I'm trying to leave around 8:30-ish at the very, very latest.